Hey there, everybody. Welcome to lesson 14. Today we're talking about fractions still, and this is about how to strategize when you're trying to solve a multi-term problem. Basically, today we're going to have problems that look like this. This is our first one, and I'll show it to you, and we'll talk a little bit here. I got 2/3. I have plus 1/5, plus 1/3, plus 1 and 4/5. This would be a multi-term problem. Multi being more than one term, right? In this case, we have 1, 2, 3. There's 4 different fractions that we're trying to add up. And so the focus is going to be on that and strategies to go about making this a little bit easier. So if we take a look at this one, this problem, 2/3 plus 1/5 plus 1/3 plus 1 and 4/5. The thing I noticed right away by looking at this is I have a third here and I have a third here, and I have a fifth here and I have a fifth here, right? And so the thing to do then would be, well, hey, I know that I can group up my thirds and I can group up my fifths, and because I'm just adding them all together, it doesn't matter what order I'm doing this in. If you would imagine apples, and let's say we have some apples here, and I got a couple here, and I got maybe like a half of an apple here. If I want to find out what's my total of apples, if I'm adding them all together, it doesn't matter if I put this one together with this one first or this one. It doesn't really matter as long as I'm just putting them all together. I'm going to get the same answer. So if we're adding them all up, we can just throw them together here. I know thirds and thirds, so let's do that. Let's put our thirds together. Oh, let's not be writing. Let's get some black on here. 2/3, and let's do 1/3. Let's add these guys up together. Well, 2/3 and 1/3, that equals 3/3, and 3/3 is equal to 1. Well, that was easy. Let's do our fifths. Let's hope it's that easy too. I have 1 and 4/5. I'm going to add in 1/5. Sure looks like it. 4/5 and 1/5. Well, that equals 5/5, and 5/5 is also 1. So I have 1 and 5/5, or I have 2. And originally I'm adding these up, so I need to add these together. I have my 1 plus my 2, and I get a final answer of 3. So in this problem, we've just paired them up, paired these guys, and found our solution. So sounds like if we have a multi-term problem like this, maybe pairing them up before adding them up. That's a really good strategy. I can do this probably even without without writing anything down, can't I? Cool. Okay, let's look at another problem then. We have 5 and 7/8, and we're going to subtract 1/2. We're going to subtract 7/8. We're going to subtract 1 and 1/2. Okay, so looking at this problem, there's a couple things right off the bat. One, obviously this is a subtraction problem, and so that's going to make things just slightly different here. When we're subtracting, we're starting with this. This is like the base for everything, our whole problem. We have 5 and 7/8, and so I want you to think about that. You have something, 5 and 7/8, and this is that something, and you want to take away all of these pieces, right? So you're going to take away 1/2. You're going to take away just a little piece, and then another 7/8 piece, and then another 1.5 piece. And so when we're going to go about, let's do some regrouping here. Let's kind of throw these numbers together, because that's going to make our life easier. We have to do some thinking about this. If I have 5 and 7/8, and I want to subtract 7/8, that should be pretty easy, right? That should be pretty simple. That should be pretty simple. 5 and 7/8. I'm going to take away 7/8. Well, that's going to leave me with 5, right? 5 and 7/8, and I have to just take away 7/8. I'm going to be left with 5, right? So now I have 5. I need to subtract 1/2, and I need to subtract 1.5. There was some discussion in class about this one, and one of my students said that you should take this 1/2, take 1/2, and you should take it away from this 1.5. So I have my 1.5. I need to take away my 1/2 and leave myself with 1. Another student in my class said, no, that's not how you do it. You need to take this 1.5, group it with this 1.5 by adding them together to get a total of 2 that you're going to be taking away. And we talked about this, and we said, well, what exactly are we looking at when we do this? And so I said, well, imagine if we do have let's say some apples. So we have 3 apples, and let's talk about exactly what's happening here. If I have 3 apples and I want to take away a half an apple, then I'm going to come and take away a half that apple, right? And then I also want to take away another 1½ apples. So all in all, I want to take away, here's my other half an apple, I want to take away this one. All in all, I'm really taking away 2 apples. And thus, this is the one that I really want. When we do something like this, you're basically saying, well, I want to take away 1½, but take off a half of that first, then I really only want to take away 1, and that's not really what the problem is asking us to do. So in the short of it, let me get rid of this kerfuffly mess right here. When you have a problem like this, you want to remember that each one of these things is something that you want to take away from this whole. And so you can group these together, but you can't get rid of one of them. You know what I'm saying? You have to make sure that you're taking them all away. So when we do something like, well, I take my 1½ and subtract this half from that, you're actually canceling out some of these and you're not taking away as much. So, make a long story short too late, what we have to do is we have to go about taking away, and we're right up here, if you remember, 5 minus a half minus 1½. I can group these two, but I need to group them by adding them together. I need to take my 1/2 and add it to my 1½ to get 2. And then I'm going to take my 5 and I'm going to subtract 2 to get a final answer of 3. I also could, if I wanted to, I could take this. I feel like I'm just writing all over the place today, so I hope you're staying with me here. I also could take my 5 and subtract a half, and if I did that, I would get 4½. And then if I did that and I subtracted 1½, well, 4 minus 1 would be 3, and a half minus a half would be nothing, and I would get another answer of 3. So, I mean, here's the thing about these problems, especially, is there's a bunch of different ways you can go about thinking about it. As long as you're keeping, especially on one like this, as long as you're keeping in mind that that's our whole, and we're subtracting these parts away from that whole, you're going to be fine. Okay, let's move on to problem number 3. And let's do 2 and 5/6. We're going to subtract 1/3, and we're going to add 1/6. So you'll see here that we have, I have a subtraction, and I have an addition. Ultimately, this is the whole that I have. This is what I'm starting with, and I want to take something away and I want to add something. So it doesn't really matter which one of these I do first. Ultimately, we're going to end up with the same answer, and we can try that. We can show you. So looking at this, a couple things I could do. I could take this and I could just add this in right away. So I could take my 2 and 5/6 and I could just add in my 1/6, and that would get me about 3. And then I could subtract my 1/3. And 3 minus 1/3, well, that would be 2 and 2/3, and I would have my answer. Another way I could go about looking at it would be, well, I can just change my 1/3. It's in the 6. I could just make that 2/6. That would be pretty easy. So I could take 2 and 5/6 minus, and I would have what was it? What did I say? 2/6 and plus 1/6. If I did that, if I have my 2/6 plus 1/6, could I do that? Can I just add that too? That would be 2/6 plus 1/6. That would be 3/6, right? Let's try it. 2 and 5/6 minus 3/6. Now that would be equals 2 and 2/6, and 2 and 2/6 would be 2 and 1/3. No, it doesn't work out, does it? It's not the same. I get the same answer. It's because we're combining these two things here, and they're not things that need to be combined. I'm taking this. I need to take this away from this, and I need to add this to this. And so when I go about combining these two things, so taking the 2/6 and I add the 1/6 to that, and then subtract that all, what I'm saying when I do this is I'm saying, well, I'm making this bigger, making the amount that I'm taking away bigger, and That's not what it's asking us to do. We have this whole, and we're only supposed to take away 2/6. We're not supposed to take away 3/6. And so when you look at this problem that way, I'm sorry, can't do it. Can't do it. I'm gonna have to cross this off. To be careful about what I'm taking away. But there is another way you can look at this problem. You could look at it as far as sixths go, and you could do 2 and 5/6, and you could subtract out 2/6, right? Which would be 2 and 5 would be 2 and 3/6, and then you would just add in your 1/6 to get a total of 2 and 4/6, which is also 2 and 2/3. So same here, same here. This one did not work out because we kind of rearranged our orders. The most important thing you can think about is saying, this is my whole, and now I need to do this to the whole, and I need to do this to the whole. Okay? All right. Problem. Let's do problem 4. This one's going to mix it up a little bit. Let's do 14/3. Whoa. Plus something plus 9/4. It's going to equal 8 and 11/12. Well, when I look at this, I see this is my whole here. This is my whole. And I got this whole by adding this and this and this. So I should be able to find out what this is if I take my whole and I subtract this and I subtract this. So let's try that out. We have 8 and 11/12. We're going to subtract 14/3. And we're also going to subtract 9/4. Okay. Now, looking at this, obviously I have some common denominators to create, right? I also have some improper fractions here. I have 14/3 and 9/4. So what do I want to do about that? I think the easiest thing to do would be to turn these back into a mixed number. So let's do that first. If I have 14/3, well, I can break that out. I know I have 3/3, right? It's going to be a whole. So 14, excuse me, how many times does 3 go into 14 here? Let's see. 3, 6, 9, 12. That's going to be 4, right? So 4 of those would be 12. And I would have 13, 14/3. So I would have 4 and 2/3. And then same thing over here. Let's count by 4 to get to 9. 4, 8, that would be 2. That would be 8, and I would have one more 4th left. So I really have this, and I have my whole here, my original 8 and 11/12. So I have to subtract out these things from it. Okay, awesome. Well, so what I can do is I can turn these into 12ths. Okay, let's do that. First off, let's do our 4 minus 2. I have 2. So I have 2 and 2/3 minus 1/4. And let's turn these into 12ths. So I'm doing that by 4 times 3. So I would have, I'm going to rewrite this over here. Where should I rewrite this? Let's rewrite it up here. I have, I'm going to have 2 and something 12ths minus something 12ths. And in order to turn 3 into 12ths, I got to multiply it by 4. So I got to multiply my 2 by 4 to get 8. 2 by 4. And up here I need to do to turn this into 12ths, to rename that 12ths, I need to multiply this by 3, so I need to multiply my top by 3. So now I have that. And 2 and 8/12 minus 3/12, well 8/12 minus 3/12 would give me 5/12. So I'm going to get 2 and 5/12. And now I'm going to bring back in my whole, my 8 and 11/12, and I'm going to subtract out 2 and 5/12. Okay, let's do the 8 and the 2 first. 8 minus 2 is 6. And my 11 minus 5 would be 6. 6/12, and I know something about 6 and 12, and that's that they are buddies. And 6 and 12 is also another way to rename that as a half. So I'm going to have 6 and 1/2. Whew. That was a big problem. That was so fun. When you're doing something like that, wow, you really got to keep track of what you're doing. The biggest thing, just to recap, that we did here was we had, let me get you a good color, was we figured out that we had this plus this plus this equaled our whole. And so what we figured we could do is we could take our whole and subtract out each one of these pieces. So we put that, we wrote that down here. And then we took a look at these improper fractions, our 14 thirds and our 9 fourths, and I just put those into whole numbers. You could keep them like that and theoretically turn them into 12ths, right? You could say, well, 3 times 4 is 12, so 14 times 4, and you would put that up there, and same with the 9 fourths times 3. And you could do it that way, and then you just have to simplify it in the end. That would be totally fine. What I did was I turned my 14 thirds into 4 2/3, and my 19 fourths into 2 1/4. And then I renamed those as 12ths, as 8 twelfths and 3 twelfths. I also subtracted my 4 from my 2, and I got 2 and 5 twelfths. And then I subtracted that from my whole to get an answer of 6 and 6 twelfths, which I reduced down to 6 1/2. Okay, cool. That's a lot. That's great. This is fun. We got 2 more. Blank something minus 15 minus 4 1/2. And I'm going to get 2, sorry, 2. It's a 7, Mr. Abbott. 7 3/5. Something. And I'm going to take away 15, and I'm going to take away 14, and what I'm going to have left is 7 3/5. So what I want to do then is I have my 7 3/5, and if I add back in this and this, I'm going to find out what this was. So 7 3/5. I got this little scribble I need to get out of my way. It's going to drive me crazy. 7 3/5, and I need to add in 15, and I need to add in 4 1/2. Well, that seems pretty easy. These are all pretty big numbers. Let's add the whole. 7 and 15 is 22. So I have 22 and 3/5. I need to add in 4 1/2. Sweet. Let's go ahead and add that 4 in. That's 26 and 3/5 plus 1/2. And then I just need to turn these into tenths, right? Easy. To turn them into tenths, I would just double this one, so I have 26 and 6/10. And I know that 1/2 in tenths would be 5/10. And so I'm going to get a total of 26 and 11/10. And that's improper. I actually have 10/10 there, that's a whole, so I'm actually going to have 27 and 1/10. That one was a lot less complicated than the last one, wasn't it? But it sure was pretty straightforward once we got going to it. These big numbers were easy once I added them together. I took my 7 and my 15 and I got 22. And then I took that and I added my 4 and I got 26. And I was left with this. I turned those both into tenths. I got my answer. Okay. Let's try another one. This one, and if I haven't been reminding you, but I really do want you to go ahead and make sure that you're trying these maybe before you watch me do it. So with this last problem, let's do it. Okay, I have 6 and 3/4, and I'm going to add in 3/5, and I'm going to subtract something, and I'm going to get 5. This way, I guess we have our wholes, and visualize something, and you add a little bit to it, and then you take something away, and you're going to get 5. So we're not going to take that much away here, are we, to get 5? 6 minus 1 would be 5. This is going to be close to 1 here in itself, though. So what we're going to do is we'll do the 6 and 3/4, and then we'll add in the 3/5, and then we'll subtract 5 to get whatever it is that was here. And looking at this, hey, look, it's our 3/4 and 3/5 again, and those are both 20ths. And I know that 3/4 is 15 20ths, right? It makes sense, 5, 10, 15, 20. And then 3/5, I remember multiplying them both by 4, and 3 times 4 is 12 20ths. And I need to add those in, because that's what I'm doing here. This whole thing minus 5 is going to equal that. So 6 and 15 20ths plus, let's add these together. 15 and 12 is 27. So I have 6 and 27 20ths. And let's turn that into a proper blah blah blah. Let's turn this improper fraction here. Let's add this into our thing here. So 20 20ths will be 1. So I have 7. So 20 20ths, and I have 7 left over of 7 20ths there. And I need to subtract 5. Well, I can do that. That's easy. 7 minus 5 is 2, and that's 2 and 7 20ths. And I have my answer. That's fantastical. Well, so here's the thing. when you're doing this, it's really important to try to keep things together, keep things straight, keep your eye on what it was that you're actually doing. Even doing this one in my mind a couple times, I had some thoughts about like, wait, do I subtract that? Do I add? So it's really important to keep things straight. Make sure you're keeping an eye on your whole, and that's what it is that you're adding or you're subtracting from, and that's it. You guys are doing fantastic. Keep up the great work, and post any questions or comments, anything you might need. Yeah, rock it out. Good job, guys. Thanks a bunch. Bye.